Yeah, there. So today we are going to solve the hard LeetCode problem named n queens, which goes like this. The n queens puzzle is the problem of placing n queens on an NXN chessboard such that no two queens attack each other. Given an integer n, return all distinct solutions to the n queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration of the n queens placement, where q and dot both indicate a queen and an empty space respectively. And there are two examples here. So for the n equal 4, there are two solutions to the problem, and the expected output of our code should look like this. And there is a second example where n is equal to 1, and obviously there is only one possible solution to this case. Right, so first of all, let's consider that the chessboard is a table with rows and columns, and if you've ever played chess, then you know that queen attacks everything which stands in her line. It could be a vertical line, a column, it could be horizontal line, a row, or it could be any of the diagonals. So first of all, I would say that we don't need this complicated way to provide our result, because obviously there is only one queen in each particular row. So each solution could be described as an array of integers where each number represents a position of the queen in each particular row. So if we would have these positions, so it's going to be the array of integers, right? Then we could map this result to the expected output. So we are going to return positions, and each subarray of numbers should be also mapped. All right, and each number actually represents the whole row, right? So for our first example, we would have numbers like 1, 3, 0, 2 and 2, 0, 3, 1. To create such a string, let's use an array of characters first. And we could create it filled with dots and then modify the particular value inside the array using our number, right? So we are creating it full of dots, and then modifying it at the particular index. So now we are just able to convert this array to string, and it is done. So how we are going to actually calculate all these positions? I suggest to create a recursion and start to check all possible positions at each particular row, starting with the row number 0. So we would try to put our queen at each possible position in the row number 0. Then we'll try to put the queen at the row number 1 respectively to our previous choice, and so on and so forward until we would reach the last row where we would not have any other options that to put the queen at the last possible column. So how it's going to look? So let's create the method named positions, which is going to return an array of integers, and we are going to use it here. If we wouldn't find any solutions for this problem, then we are going to just return an empty array. So what we are going to use to calculate these positions? Well, first of all, let's create the array of possible columns which could be used at each particular step. So initially it's going to be the set of integers from 0 to n minus 1, right? And at each step we are going to pick one number from this set and try to pass the rest to the next step. Another thing which we would need is going to be all the previous positions of the queens, which we've already put at the previous steps. So initially it's going to be empty. However, if we are going to put any number to these positions array at each particular step and then remove it if the check would be unsuccessful, then we are going to allocate and deallocate memory pretty often. So instead, let's just create the array of this particular size, which contains zeros, and use only a part of this array at each particular step. And for that, of course, each particular step would need to know the row number where we are trying to put our queen. So we're going to use the row. We are going to use the previous positions. To save up on memory, it's going to be the in-out array. And last, we would need a set of possible columns to pick from. Good. So as this is a recursion, we need to finish it at some point, and this point is going to be when we would check the last row, basically when our possible columns contains only one single value. So let's check the size of possible columns. So if it is 1, then we are going to end our method execution. Otherwise, we are going to continue. So if we are at the last row and we have our column, we can get it like this. with force unwrap, because we are sure that the possible columns is not empty. So how we could be sure that this column could be used? Basically, we have possible columns which exclude all the columns where other queens are already placed. Also, we provide only one position in a row for each queen, so we don't need to check any rows or columns for intersections, but we need to check all the diagonals. Let's create a separate method for that. Check diagonals, and we are going to provide the row number, the column number, and all the previous positions. Let's also use the in-out here, and it's going to return the Boolean value. Basically, if everything is okay, it returns true, otherwise it returns false. So we are going to check all the rows from 0 to our row, and if everything is okay, we are going to return true from this method. Here we would check the value of the column at this particular row. So this is where we put our queen at some previous step. How we would know that this particular column at this particular row is some kind of coordinate which stands on the same diagonal with this row and this column. So if you think about it, you would notice that the distance between these rows and these columns should be equal. In this case, it would mean that these coordinates stay on the same diagonal. So if we would have the row distance, which is row minus check row, and if we would have the column distance, which is an absolute value of the check column and column, we are using the absolute value because we are not sure which one is greater. So if those distances are equal, then these coordinates stay on the same diagonal, and we should return false from this method. Okay. So now let's use this method here to check our column. So if we are checking diagonals for this row, for this column, and for these positions, and if it's okay, then we should return our result. Otherwise, obviously, we should return nil. So what the result is going to look like? So first of all, we are going to copy all our previous positions, right? Result is okay. And now we need to place our column at the index of row to fill the last gap. And now we are finally able to return the result. So this is where our recursion is going to end. but how it's going to behave in the middle. So basically, we are going to try to put our queen at each possible position at this particular row, and combine all possible results to some kind of array. So let's create this array. It's going to name the result. So it's going to be the same type as the result of the method, right? And it's going to be empty. Here we are going to calculate that. So if result would stay empty, then there is no reason to return an empty array. Let's just return nil. Otherwise, we are going to return the result. So, as I said, we are going to iterate through all possible columns in our possible column set. And we would try to use each particular value in this set. So first of all, of course, we are going to check the diagonals again for each particular row and column couple. Yep. So if it is okay to use it, then we are going to continue. Otherwise, we would just skip this whole iteration. All right. So the diagonals are fine, the columns are fine. So we can proceed just to the next step of our recursion. For that, we are going to create the new possible column set, right? Which is going to be equal to our current possible column set. However, we would, of course, remove our current value from that to reduce the choice. And of course, we should also put our value at this particular row in the previous positions to let the code on next iteration know where we try to put the queen at this particular step. And finally, if we would have the positions from the next step, then we are going to extend the result with these positions. So how the next step is going to look: we are going to increase the row, we are going to reuse the previous positions array, and we are going to use the new possible column set. I guess this is it, and we are finally able to check if the code works. So let's first check on our test case. We got some compilation problems here. Of course, we didn't provide the arguments for the first iteration, so it's going to be row number 0. It's going to have these possible columns, and it's going to have these previous positions. All right. Still, we have some compilation errors. This time missing the check diagonals. Let's just ignore it like this. Come on, come on. Yep. So these two test cases work, and we can finally submit our solution and check for the outcome. Yeah, so as you see, it takes a few milliseconds to execute. 1, 2, 3, 4. Sometimes it goes even on the edge of the threshold and shows 0. In this case, it beats like 100% of other solutions. And I guess this is it. So if you'd like to see me solving another LeetCode problems, please put your request in the comments, and I see you next time. Cheers!